this is section 5.5, and in section 5.5 we start talking about things that have a different kind of base. So this first couple of slides are basically just a review of things that you should have covered in Algebra 2 or in pre-calculus. So let me pause this one. Okay, so let's talk about definition of exponential function to base A. So first of all, if A is a positive real number, so A is just a number and it's positive and it cannot equal 1, and X is any real number, then the exponential function to the base A is denoted by a to the x and is defined by a to the x equals e to the natural log of a times x. This is just another way to write a to the x. Okay? These are also some properties of exponents that you should have learned in algebra. Just to review, anything to the 0 power is always 1. When I have the same base, I add the exponents when they're being multiplied. When I'm dividing something that has the same base, I subtract the exponents. And then when I have a power raised to a power, I multiply those. Okay? The next definition is just another way to write a definition of logarithmic function to base a. If a is a positive real number and a cannot equal 1, and the reason a cannot equal 1 is because the natural log of 1 is 0, and x is any positive real number, then the logarithmic function to the base a is denoted by log base a to the x, so that's how I would read this, log base a to the x equals, now there's a typo right here, it should say 1 over the natural log of a. So you need to fix that, times natural log of x. So another way to write log base a of x would be 1 over natural log of a times the natural log of x. Okay? And again, here are just some properties of inverse functions, so just different ways to write our logarithms, one in exponential form, one in logarithmic form. The logarithmic function to the base 10, that's our common log. So we have natural log when our base is e, common log, log when the base is, common log is used when our base is 10. Natural log is used when our base is e. All right? So you're going to have some problems in your assignment where it has nothing to do with calculus. They're just having you use properties of logarithms to solve for x. All right? And the reason they have you do that is because sometimes you may have to rewrite the problem in order to take the derivative using properties of exponents. So let's look at a. There's actually two ways you can solve a. I have 3 to the x equals 1 over 81. One way you could learn to solve this is in Algebra 2, I learned that you need to write both sides with the same base. Well, my base on the left-hand side is 3. So that means I need to write 1 over 81 as 3 to some power. So let's just, instead of 1 over 81, let's just do 81. Well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I know 3 to the 4th is 81, but since this is 1 over 81, it would be to the negative 4th, because when I have a negative exponent, I put that down on bottom. So then, when we have the same base, we can set our exponents equal to each other, and we know that x is equal to negative 4. So that's one way to solve. Okay? The other way we can solve is, I know that anytime I'm solving for something, and I have x up there as an exponent, okay, I can use logarithms so that I can use the properties of logarithms to bring that exponent down. So for example, I could have worked this one this way. Log both sides. Now use properties of logarithms to bring that exponent down. So now I have x log of 3 equals log of 1 over 81. And then solve for x. Divide by log 3. So x equals, now I know this looks weird, but if I put this in my calculator, when you have a log button on your calculator on the left-hand side, when I plug this in, I get negative 4. So either way, you're going to get the same answer. Okay, let's solve part B. log base 2 of x equals negative 4. Well, when we solve this, okay, we need to write this in exponential form. So what is my base in this problem? My base is 2, so 2 is my base. Your exponent is always the number over on the other side of the equation. So it's going to be 2 to the negative 4 equals x. And then x equals whatever 2 to the negative 4 is, 1 over 16. Okay? So now they introduce some new derivatives. All right? Now it's very important. You have another typo on your paper. This right here should be written a to the x. So the derivative of a to the x is the natural log of a times a to the x. The derivative of a to the u, same rule, but if I have anything other than x, then I have to multiply it by its derivative. The third one is the derivative of log base a of x equals 1 over the natural log of a times x. And then rule 4 is just like rule 3, but I have to multiply by its derivative. So let's look at some of the examples of what they would look like. Okay, I put these up here for us to look at. And again, this is a to the x. Find the derivative of each function. Well, which rule would this be? Okay, remember, a is always a constant, and x is my variable. Okay, so this is rule number 1. All right, and if it helps you, my a is 2. All right, so it says natural log of a, so y prime equals natural log of a, and a is 2, times a, or 2 to the x. And that's my answer. Let's do part B. Y prime equals, this is my a, so natural log of 2, and then it's 2 to the 3x, because it says a to the x. But then I have to multiply by the derivative of my 3x since it's something other than just an x. So multiply that by 3. Okay, now you have to be careful. You can't multiply this 3 by any of these 2's, so I normally bring that 3 out in front, and it would look like this. All right, now part C. Part C is going to follow rules 3 or 4. Okay, so I have log base 10 of cosine x. All right, so let's kind of label what my a and what my u are. My a in this problem would be 10. My u would be cosine x. And I just kind of do that so I know what to plug into these derivatives. So y prime equals 1 over natural log of a, and we said my a is 10. All right, times derivative, or times x, okay, or natural log base a of u, so natural log of a times x. And I'm looking to see if that's a typo right there. That should say u right here. U. So my u is cosine x times the derivative of my cosine. Well, the derivative of cosine is negative sine. All right, now you could leave your answer just like that, or you could write it as negative sine x over natural log of 10 times cosine x. But we know we can simplify sine over cosine. Sine over cosine is tangent. So really I have negative tangent over natural log of 10. Okay. Example 4. Oh, I'm sorry, example 3. Now you are going to learn a new integral. The integral of a to the x is 1 over natural log of a times a to the x. So this one would be 1 over natural log of 2 times 2 to the x plus c. Okay, example 4. Okay, example 4. Now I can break this up into two separate integrals. It's really this 5 to the x minus 3 to the x. Okay, now this time this is a definite integral. So I'm not going to put a plus c. I'm actually going to evaluate my upper and lower limits. So we know that this is going to be, if I follow this, whoops, let me get back to where I'm needing to be. Oh, if I follow this integral, it's going to be 1 over the natural log of a, and my a right here is 5, times 5 to the x, minus 1 over natural log of 3 times 3 to the x. Now I'm going to evaluate from 0 to 1. So now I can plug in my numbers. 1 over natural log of 5 times 5 to the first minus 1 over natural log of 3 times 3 to the first minus, now I'm going to plug in 0. 1 over natural log of 5 times 5 to the 0 minus 1 over natural log of 3 times 3 to the 0. All right, so now let's simplify. 5 to the first, that's really 5 over natural log of 5 minus 1, minus 3 over natural log of 3 minus 5 to the 0 is just 1. So that's going to be 1 over natural log of 5 minus a negative, so that's plus 3 to the 0 is 1. 1 over natural log of 3. Now here's the deal. Even though these look weird, these are just numbers. Natural log of 5, I can put that in my calculator. It's going to give me a number. So I have a common denominator. These are just fractions, which means I can add together my 5 over natural log of 5 minus my 1 over natural log of 5 because they have a common denominator. So that's going to be 4 over natural log of 5. And then I have a negative 3 and a positive 1 over natural log of 3. So that's minus 2 over natural log of 3. And that's my answer. Okay. Example 5, I'm finding the derivative of some function. So I just threw in some all kinds of different derivatives for you to find. Okay. This is, and it's kind of hard to see. I need to find the derivative of e to the e. The derivative of e to the e. Well, remember, e is just some number, 2.7, raised to the 2.7. So isn't this just a constant? So if this is just a constant, my derivative is 0 because the derivative of any constant is 0. Okay? The derivative of e to the x. Well, we learned the derivative of e to the x is e to the x. Part C, I have x to the e. So I want to find the derivative of x to the e. Well, remember, e is just a number like 2. Well, how would I find the derivative if this was x squared? I'd bring down my exponent and subtract 1 from the exponent. So that's what I'm going to do here. Bring down my exponent and subtract 1 from the exponent. And then part D, I have y equals x to the x. Now this one's a little different because I have a variable raised to a variable. All right, there are no rules for this. This does not follow the rule for a to the x because a has to be a constant and x is not a constant. So when you have a problem where you're finding the derivative of a variable raised to another variable, okay, we're going to have to do what we call logarithmic, I just lost the word for it, logarithmic differentiation. So I'm going to find the derivative, but before I do that, I'm going to have to change this. I cannot leave it as a variable raised to a variable. So one way I could fix this is to take the natural log of both sides. So if I do natural log of y equals natural log of x to the x. Now I'm going to use properties of logarithms to bring that x out in front. So now I have this. Natural log of y equals x times natural log of x. Well, now I can find the derivative of this, but since I have y's and x's, I have to do implicit differentiation. So the derivative of natural log of y is 1 over y, but next to that I have to have a y prime. This is going to be the product rule. Here's my first term, here's my second term. So my first term is x times the derivative of the second, which is 1 over x, plus my second term times the derivative of the first. Okay, so let's simplify this a little bit. This is really y prime over y. X over x, that's just 1 plus natural log of x. Now I have to solve for y prime. So to solve for y prime, I'm going to multiply both sides by y. So these cancel. I have y prime equals 1 plus natural log of x times y. And then I know what y is. Y is x to the x. So I'm going to replace that y with x to the x. So y prime equals 1 plus natural log of x times x to the x. And that's my answer. Okay. So I think the numbers that you're supposed to do are at the top of your notes. So that's going to be your assignment.